Okay, I'm going to show you how to do the calculations for the 2.5 free fall lab. At this point, everybody should have values for their acceleration for both the ball and the textbook. So you should have an acceleration for textbook, and you should have one for the ball. I'm just going to make up some numbers here. So let's say I got negative 7.8 meters per second squared for the acceleration of the textbook, and the acceleration of the ball I got negative 10.2 meters per second squared. These numbers, I just made these numbers up, but your numbers should come from LoggerPro and the slope of the velocity versus time graph. To find the average of these two values, I add them together, negative 7.8 plus negative 10.2, and I divide them by 2. In this case, I would get 9.0 meters per second squared. So that would be my average of the two accelerations that I found in the lab. So now we're going to find the percent error for the average acceleration due to gravity. This was a negative 9. The accepted value from our class is negative 9.8 meters per second squared. But we're just going to call it positive 9.8 to make our numbers a little bit easier. Positive 9.8. So for our measured value, I'm going to take the one I got up here, but I'm just going to make it positive 9.0 meters per second squared. To find percent error, we find the difference in the accepted value and the measured value. So we do 9.8 minus 9.0, and then we divide it by the accepted value, 9.8. Then we multiply by 100%. So 9.8 minus 9.0 is 0.8. The bars here, these bars, are absolute value bars. That means if I got a negative number, like if I got negative 0.8, the absolute value says make it positive. So all these numbers should be positive. Whatever number you have here, just make it positive. So I've got 0.8, still divide by 9.8 times 100%, and then 0.8 divided by 9.8 is 0.0816 times 100%. So multiplying that by 100, I actually get 8.16%. So that's 0.8 divided by 9.8 is 0.0816 times 100%, I get 8.16%. We're going to use this percent error in our reasoning. Right? So if we go to the next page, we're going to make a Google document. We're going to title it 2.5 Free Fall Lab, and we need all of these sections. Make sure that you put your name at the top and a title, and make sure you label each section. So in your Google document, you should have the purpose, which you can find right on the front page. That's the one thing you're allowed to copy directly. Then the next section are your graphs. We have a ball and we have a textbook, and each one of those has a position versus time graph and a velocity versus time graph. So that's 4 graphs total. You need to include all 4 graphs in the Google document. Make sure that you scale your graphs so that I can actually read them. Otherwise I'll take points off. Just copy and paste them in, Command C, Command V, or take screenshots, but just make sure I can see them easily. Then you're answering these questions. What is the shape of the position versus time graph? Was it linear, horizontal, or was it curved in some way? And what does the shape of the graph indicate about the speed of a freely falling object. So the fact that it's whatever shape it is, what does that tell you about the speed? Then you also want to answer the question, what is the shape of the velocity versus time graph? Again, is the velocity versus time graph linear, horizontal, or curved? And what does that shape tell you about the acceleration of a freely falling object? This is really question 1 and question 2. Then the next section we have our conclusion, which is the most important part. Your conclusion has claim, evidence, reasoning, and error. So your claim should answer the purpose, and it's kind of rewritten here as a question. Do all objects fall at the same rate on Earth? What is the acceleration of free-falling objects due to gravity on Earth? Okay, so your answer should be something like, all objects fall at the same rate on Earth, and that acceleration of free-falling objects due to gravity on Earth is, and then your average acceleration that you got. Okay. Your claim must fit with your evidence and reasoning. So let's talk about that. Your evidence are your two accelerations and the average value of them. The reasoning is, sorry, what I said before, the claim was a little off. You should be saying something like, all objects fall at the same rate on Earth, and that acceleration due to gravity is, and then you should use the number that we say it is, the number that we're comparing our LogRPro data to. Because in the reasoning, we want to try to support our evidence, support our claim. So the reasoning, we're going to take our percent error, which we did earlier, and we said basically percent error is how different is our value from the accepted value. And here I'm saying my difference is about 8%. It's 8.16% different from the accepted value. So if your percent error is less than 20% of the accepted value, or less than 20% different from the accepted value, then we can consider that accurate. Meaning, for mine, this percent error is less than 20% different from the accepted value. 8% is less than 20%. So I'm verifying, yes, that is our accepted value. Now, shouldn't we get the exact same thing? Shouldn't we get 9.8 here and 0% error? We would, except that there are lots of errors in this lab, things that we can't change. So we'll talk about that in the error section. But again, if your percent error is less than 20%, then you can say that your acceleration is that negative 9.8 meters per second squared. And then the last part you need in the conclusion is the errors, the source of error, and how they would affect the calculated acceleration due to gravity. So that's really saying, you know, why didn't we get negative 9.8 meters per second squared exactly? If you can think of what happened in the lab that would make our numbers different from negative 9.8 meters per second squared, then that's going to be an error. The errors are not calculation errors, so it can't be that you did the average wrong. And they're not experimental, no, sorry, they're not calculation errors are not experimental errors. And they're not human errors in the sense that I wrote the wrong number down. But there were things that we couldn't change that affected the acceleration. And there's something to do with the process of how we found the acceleration using LogRPro that gave us some error. So I'm not saying that LogRPro did something wrong. I'm saying some way that we used LogRPro may have led to some errors. So you write all of that in a Google Doc, and that'll be due on Wednesday. not Monday but Wednesday. So you have 6 days to do it.